The arrival of 3G, smartphones, mobile cloud computing and video streaming has triggered a huge demand for bandwidth in operators' networks. Mobile operators are responding to this demand with 4G long-term evolution networks, enabling richer applications and faster connectivity. In metropolitan areas, small cell networks will be deployed to provide more capacity and faster mobile broadband to end users. As the number of users increases, operators will be forced to increase backhaul capacity, since most of these cells will require 100 megabits per second or more to deliver the promised superfast mobile broadband. Today, the biggest challenge will be to provide this capacity with scalable and cost-effective backhaul. In particular, the power of millimeter wave in the Q-band, combined with the convenience of point-to-multipoint architectures, has been proposed as a promising solution to provide the capacity and cost figures required for small cell backhaul and last-mile access. Indeed, this solution can deliver multi-gigabit capacity with massive savings in equipment, site rental and licensing costs. However, with the state-of-the-art Q-band technology, this system has some limitations in terms of range, or in the number of base stations connected. To overcome this limitation, novel Q-band technology must be developed, and this is where the SARABAND project comes in. The EU-funded SARABAND initiative brings together technology and system experts from 9 organizations across Europe to develop disruptive millimeter wave technology on antennas and radios, providing final network performances comparable to fiber optics for 2 main applications: 4G small cell backhaul and broadband access. Over the lifetime of the SARABAND project, new low-profile high-gain antennas, programmable multibeam antennas and miniaturized front-end radios have been developed to bring important benefits in terms of performance, cost reduction and compactness. At the end of the project, all the technology developed in SARABAND has been integrated in a wireless network platform deployed at the campus of the Polytechnic University of Valencia in Spain. The deployment consists of the interconnection of 5 sites through millimeter wave wireless links in a point-to-multipoint architecture. A clean line of sight is required between the different rooftops in order to achieve robust and error-free links in the 40 GHz band. 3 types of nodes are employed in the SARABAND deployment: terminals, relay nodes, and a transmission hub. The terminals are placed at sites simulating network endpoints, where high bandwidth interconnection is required, and are served by relay nodes. These relay nodes are served by the transmission hub, which is the central point of the deployment, where the capacity is distributed over the different sites covered by this point-to-multipoint sector. If we look at terminals 1, 2 and 3, they are served by relay node 1, where an innovative multi-beam lens antenna aims at each terminal with one of the lobes of its radiation pattern. Relay node 2 links to terminals 4 and 5, which are configured to share the capacity of one channel. Both relay node 1 and 2 are connected to the transmission hub. The link between relay node 1 and the transmission hub is the longest link of the network, with around 1.1 kilometers, site 1 and site 2. In order to provide connectivity and monitor the deployed network, a dedicated optical fiber link allowing gigabit Ethernet is employed between the SARABAND Network Operations Center in Site B and the transmission hub in Site 1. At the Network Operations Center, real-time and historical statistics can be obtained, and the status of the different network elements is monitored. In particular, a network monitoring system software has been set up to obtain indicators of the performances of different network elements. In the event of a network failure or a degradation of the performances, the NMS will generate alarms, and the operator will be able to make decisions based on that information. The NMS also keeps a database with the historical values of the key parameter indicators of the system. In SARABAND, the NMS continuously pulls information from the radio modems on which the wireless links rely. Bandwidth, drop frame rate, received and transmitted signal strength are continuously monitored. The SARABAND system performances have been measured with specific equipment designed to certify the stability of the links in a maximum capacity scenario. After that certification, the system is continuously tested and monitored by using software generating traffic. The system has proved high stability and high capacity of the millimeter wavelengths, with over 100 megabits per second peak capacity in the higher modulations and arid frame rates compliant with Tier 1 and Tier 3 operators' requirements. SARABAND Demonstrator connects 5 different terminals to a high-speed point-to-multipoint network. Let's imagine 4 different application scenarios in the deployed network. A first scenario would involve Terminal 1, which could be a mobile operator cell site with a 4G base station, requiring a dedicated backhaul channel of up to 120 megabits per second. Terminal 2 could be a small or medium-sized company requiring a broadband internet service. Such a company would require a bandwidth in the range of 50 to 100 megabits per second, depending on the number of employees. A third scenario could involve Terminal 3 giving support for an IP-based video surveillance system. This system requires stable broadband connections to send video streams and alarms. Finally, Terminal 4 and 5 in the SARABAND deployment are configured to share the capacity of a single channel of up to 120 megabits per second. This configuration is typical in residential access networks where the available capacity is distributed dynamically among the subscribers. In SARABAND, the new functionalities provided by these innovative antennas and smart radios, coupled with a multiplex of wideband modems, achieve novel network nodes with multiple high-capacity links in programmable directions, providing better coverage and greater capacity together with TCO reduction.